Section 6, Video 1. So far we've talked about two other ways to solve a system of equations. First was to solve by graphing. And when you solve by graphing, you have what we would consider an approximate answer. Then we said you could solve by substitution. And by solving by substitution, you would get one of the equations, solve for a variable, and then you can do substitution. But now we're going to talk about the third way of solving a system, and that's elimination. Now, if we ask you to solve by one method or another, you have to solve by that method. But if you're just given a general question, without the specifics of how you should solve it, you have a choice. So some of you may prefer substitution over elimination, or vice versa, and it's up to you. But what we're trying to impress upon you is that given a question, and you look at it wisely and strategically, is it set up already in its original form that would best be solved by substitution or best be solved by elimination? And we'll get to that at the very end of this section, and how to decide. But if we're going to solve by elimination, we have to learn it first. Okay, so this is not new to us. So if you look through the rules here, it says you would solve by elimination by adding or subtracting, but if you remember from previous years, we do not solve by subtraction. We would solve by adding, and we'll talk through a couple of those examples. All right. But when we add the two equations, one of the variables will drop out, and then you can solve for the last one. Both equations should be written in standard form in order for you to do elimination. And some key points here is that we are looking for opposites so that when we add them, things will cancel. If we have opposites, then we can go ahead, this is a yes now, we can go ahead and add the equations together and solve for the remaining variable. If we do not have opposites, then we're going to have to multiply one or both of the original equations so that we can create opposites. Once you've done that, you can go ahead and add them vertically, and you would cancel out a variable in doing so. Note, if all the variables drop out when using elimination, then you're either going to get a true statement or a false statement, as I mentioned with substitution. If you get a true statement, infinite solutions. If you get a false statement, no solutions. And this is the same rule that you go by when solving by substitution as well. So that is consistent. And this ends Section 6, Video 1.